Okay, today we will be discussing about factoring difference of two squares. What is the general form of the product of a sum and difference of two terms? Yes, that's right. We simply get the difference of the square of the first and last terms. On this activity, you will recall how to find the product of the sum and difference of two terms. Okay, pause the video while you answer, then play it again to show the answers. Okay, let us check. So to get the product of quantity x minus 5 times the quantity x plus 5, square the first term. The square of x is x squared, and the square of 5, the last term, is 25. So what would be the first term of the product on the second item? Yes, very good, 16. And for the last term, it is y squared. For the third item, getting the square of 2a, yes, that is 4a squared. And getting the square of 3b, that would be 9b squared, correct? And lastly, to get the square of 4m squared, the answer is 16m raised to 4. And the square of 6n is simply 36n squared. After having a recall on getting the product of sum and difference of two terms, do you still recall how to get the square root of perfect squares? Let's test if you still remember by this another activity. How to get the square root of perfect squares? Square root of 9 is 3, and square root of 121, that's right, it's 11. And square root of x squared, wait, is x squared even a perfect square? How do we identify? So it is a perfect square if the exponent can be divided by 2. So 2 divided by 2 is 1, therefore the square root of x squared is x. And for the square root of 144y squared, get the square root first of the number. Square root of 144 is 12. Then square root of y squared is y. So the answer then is 12y. And lastly, square root of 16 b squared c raised to 6. That would be, yes, 4b c raised to 3. As we have observed in our recall on getting the product of the sum and difference of two terms, the answer is the difference of two squares. So our topic today, which is factoring the difference of two squares, is simply the opposite or the reverse of getting the product of sum and difference of two terms. To factor difference of two squares, we simply have two steps to follow. First is get the square roots of the first and last terms. And second, write the factors as the product of the sum and difference of two terms, quantity a plus b times the quantity a minus b, where a is the square root of your first term and b is the square root of your last term. For example, we have the difference of two squares, x squared minus 9. To get its factors, first, get the square root of the first and the last terms. The square root of the first term, x squared, equals x, and the square root of the last term, 9, equals 3. Second, write the factors as the product of the sum and difference of two terms, quantity a plus b times the quantity a minus b. which makes the factors of the difference of two squares quantity x plus 3 times the quantity x minus 3. Therefore, the factors of x squared minus 9 are quantity x plus 3 times the quantity x minus 3. Okay, so how about you try this another example by yourself? Get the factors of 4x squared minus 81. Okay, I hope you got them right. Let's see. Get the square roots of the first and last terms. For the first term, you have 2x, and for the last term, 9. Rewriting them as the factors or the product of the sum and difference of two terms, your factors should be quantity 2x plus 9 times the quantity 2x minus 9. And that makes the factors of the difference of two squares 4x squared minus 81. For instance, you have this difference of two squares. What will be its factors? Let's check it out. First term and last term get their square root. Okay, then rewrite them as the product of the sum and difference of two terms. Okay, so then the factors are quantity 5 plus 7x cubed times the quantity 5 minus 7x cubed. Okay, did you get it right? Okay, so let's try to solve another one. Find the factors of 16e raised to 8 minus 121f raised to 12. Okay, what are the first and last terms? Get their square roots. Yes, it's 4e raised to 4, and for the last term, it is 11f raised to 6. Rewriting them as product of the sum and difference of two terms, we get the factors quantity 4e raised to 4 plus 11f raised to 6 times the quantity 4e raised to 4 minus 11f raised to 6. For our last example, it is quantity x plus 1 squared minus 64. What have you observed? Is this still a difference of two squares? If the first term is a binomial that is squared and the last term is 64, is this a difference of two squares? Can the exponent 2 of the binomial be divided by 2? Yes, it can be. So, get the square root of the first and last terms. Okay, getting the square root of the quantity x plus 1 raised to 2. Okay, simply dividing the exponent 2 by 2. Okay, we will be left with the binomial x plus 1. And square root of 64 is of course 8. And how do we write them as factors? So we will use brackets because we have parentheses inside. So we have the sum of the binomial x plus 1 and 8 and the difference of the binomial x plus 1 and 8. Okay, thank you for watching.